Hi everyone, welcome. This is going to be the first video lesson for this semester, the fall 2022 edition of RTA 838, Generative Processes. And in this first lesson, we're going to be taking a very gentle introduction into ideas on generative systems. We're going to create something built on the concept of a grid. And then within that grid framework, we are going to explore how randomness and program structures can help us be expressive with our code. So let's jump right into it. So this grid framework is really going to be based on 10print as a point of departure, the project we talked about in class. 10print is this classic Commodore 64 program that is only a single line of code here, and that basically generates an output that looks like this on the left. So it's a grid-based program where every cell in the grid can be one of two different patterns. In this case, either a forward slash or a backward slash. And the result is this kind of intricate, complex looking but simple to generate tapestry. So what we're going to do today is we're going to explore this idea inside p5.js. We're going to be using p5.js for all of these tutorials in the course this semester. The reason we're using p5.js just because it's easy to share work in p5. It's easy to develop in the browser and easy for you to take the work that you've made and share it with others. So we could have used any number of other environments, but we're going to stick with p5.js for this course. It's going to serve us well as far as exploring generative concepts. So yeah, let's just get started. For many of you, this is going to be you've probably already seen p5.js in a different course. If you haven't, I'll point to some resources where you can brush up on some concept, especially if you're coming from processing. A lot of the ideas are similar, and these first few tutorials this semester, I'm also going to be spending a little bit of extra time kind of re-explaining some of the basic concepts as we go. So this week, I said we're going to explore the idea of a grid. So we're going to do a few things. First, we're going to develop kind of a very simple grid framework for us to play within inside P5. So this is going to be our first step. We're going to essentially emulate what 10print does with the forward and backward slash. And then once we get there, we're going to talk about how we can structure our code to then open the door for us to do some more interesting experimentation. We're going to add more than two possible patterns for each cell. And we're also going to talk about how we would create sort of different levels of probability instead of always being a coin toss in each cell, right? Could we change the ratio at which some of these patterns would occur in order to sort of further be able to tweak and customize the types of patterns our software is able to generate? But let's start at the beginning here, and let's start by building a grid. So the first thing we're going to do is declare a variable here. I'm going to call it gridSize. And the idea with this variable is going to be to define the size of our grid cells in pixels. There's lots of other ways we could think about defining the grid. We could also specify the number of cells we want and so forth. We're just going to approach it from that perspective. We're also going to expand the size of this sketch here to fill the entire window using window width and window height. And then finally, we're going to use a black background. Okay. So if 20 by 20 is our grid size, then we can easily generate a grid by writing two nested for loops. And we're going to use this as our sort of step counter. We're going to count in increments of grid size to generate a sequence of X and Y values that are going to make up all the coordinates in our grid. So a for loop in JavaScript uses the keyword for. And the for loop always follows the same recipe. First, we declare a variable we're going to use to count with. Let's start with the X values. So we'll say let X equal 0, start counting from 0. Then we define a condition that's going to tell the for loop when it's time to stop. So as long as this condition is true, the for loop repeats. So here we're going to say as long as X is less than width, we're going to keep repeating. And we're going to increase X in steps of grid size. So that's going to count 0 and then 20, 40, 60, and so forth. So that's going to generate all the x values on the x-axis. And then if we want a grid, all we have to do is inside this for loop, we're going to put a second one that's going to go ahead and also generate the rows, right? So we're going to get the columns and then the rows. And because they're going to be, this one is nested inside the first one, it's going to eventually generate all the combinations of rows and columns to form a grid. So this one we're going to call y, and we're going to say as long as y is less than height, repeat, and we're going to increase in steps of grid size. So this is a very common pattern in programming. Whenever you want to generate pairs of values that make up a grid, or maybe it's pixels in an image or whatever it is, these nested for loop patterns are very common. So inside this inner for loop, we know that we're going to have access to all the different combinations of x and y. Okay? So just to test this, we could draw a circle at x and y, and then let's make that circle the size of our grid, and then let's hit play. Okay? And there it is. This is our basic grid framework. Now, a grid may seem like a really simple thing, but in the context of generative systems, there's a lot of fun things we can do that are grid-based. And we'll explore some of these ideas in other lessons, perhaps. But a grid, essentially, one way you can think of it is some kind of a constraint you're imposing on your program, right? So you're constraining the form to a grid, but then within the grid, you can do all kinds of randomness, right? So it allows you to create some form and give things shape, without things devolving into pure chaos. So in this course, we're going to be interested in randomness, but controlled randomness, right? So how do we apply constraints and parameter to random values so that we can get programs that are never repeating, but still have some structure to them. So the grid is a great example of that. Now, instead of drawing a circle, what we're going to do here is we're going to translate the origin into the top left corner of each of these grid cells. We're going to use translate. Translate. We're going to translate to x and y. And because we translate, we don't want these translates to be cumulative. In other words, every time the loops repeat, we want the origin to be in a new cell. So we're going to use push and pop before and after we translate. So push, remember, whenever you use transformations in P5.js, whether it's translate, rotate, or scale, push will save the state of the origin, and then pop will restore it the way it was when we pushed. So this allows us to say, okay, save the origin, which is up here, 0, 0, then translate to the location of our grid cell. And then in here, we can do whatever we want. Just to show that this works, we could now draw a circle at 0, 0, and we would get a similar result. Okay, let's make it smaller just so we see a difference. Okay? So this still works. Now, instead of drawing a circle, we're going to start by drawing, getting inspiration from 10print. We're going to draw those lines that 10print does so we can recreate that maze-like pattern. And because we're eventually going to do a bunch of stuff in here inside the inner for loop, we're going to create a little function to hold the code that is going to be responsible for drawing our pattern. So let's call this draw pattern. And then down here at the end of draw, right after draw, we're going to declare a new function. This is the syntax to declare a function. We use the keyword function. We give our function a name. This function here in this case doesn't have any parameters. I'm just going to use it as a container for code. And the reason I'm doing this is just to kind of keep things manageable. So instead of starting to build my code in here inside these for loops, I'm going to move into here, right? So now I have a bit more of a clean slate, knowing that every time draw patterns gets called, right, this translate here is going to take care of moving the origin around for me. So now all I have to worry inside draw pattern is what is the pattern I want to draw in my little cell that is grid size as its dimension. Okay? So for instance, we could go in here and say we're going to draw a backward diagonal line. Okay? Backward diagonal. So we could say draw a line from 0, 0. So that's going to be the top left corner of our cell, and go to grid size and grid size. That's going to be the bottom right corner. And if you're not convinced of this, just draw it on a piece of paper. And of course, the line should not be black. So let's set a stroke of white. Otherwise, we're not going to see much. So now we have a forward diagonal in each cell of the grid. Okay. So we're halfway to 10 print. Let's do the oh, actually, so this is a backward. Let's do the forward diagonal now. So forward diagonal, this is going to be, it's going to start on the bottom left, right? So 0 on the X and gridSize on the Y, and it's going to go up to the top right. So gridSize on the X and 0 on the Y. Okay, so this is the other diagonal, and we should see a bunch of X's, or I guess in this case, we get a full diagonal grid. Now what 10 print does, its kind of simple concept is that at each location in the cell, it flips a coin and it draws one of these two patterns. So we can easily do that in P5 using the random function. So we could say, let a variable called R. Here I'm going to use lots of sometimes unnecessary intermediate variables just to make sure the code is as clear as possible. We're going to create a random number here. And at this point, we could do whatever we want. Okay. One thing I like to do, that's how I like to think of it just naturally with these random numbers, is I'll say, let's create a random number between 0 and 1, knowing that it's going to be a float. Okay. And then if I want something to happen half of the time, right, I'm going to say if R is less than 0.5, or another way to look at this is 50%, right? Then if that's the case, we are going to draw this line. And I guess else, we are going to draw that line. Okay? So now we're generating a random number, and then half the time we're going to do one line, and then the other half we'll do another line. Now, obviously, the sketch here gets a little crazy because remember, draw repeats over and over. It's just constantly generating new patterns. So we're going to put the brakes on here, and we're going to call noLoop, which is basically a pause button. So we're going to pause at the end of our first frame. And now we can see a still image of the pattern we just created. So pretty neat. And one thing we could do here as well is we could tie the stroke weight before we move on to more elaborate things. We could tie the stroke weight to our grid size. And the reason I'm going to do this is going to become clear in a second. Let's say we're going to set a stroke weight here of a grid size. I don't know, what's a good amount? Let's start like this. So if you multiply anything by a small decimal, right, it's like taking a percentage of that number. So this is the same as saying 20% of the grid size. Okay. So that actually looks pretty good. And the idea behind this is that if we start to tweak our grid size, which is something we're going to want to do a lot when we're writing generative software, we're going to give ourselves a series of parameters and variables that we can control. And then, we're going to make it so that some elements of our program are going to kind of naturally unfold from these variables. For instance, if I decide, let's see what this would look like with a bigger grid size, 60. Now my grid remains kind of like a thick line, whereas before this grid would remain a 1 pixel by 1 pixel grid. Okay, this is just a design decision. Again, there's no right or wrong here. Or the other way around, if we make this a very small grid, try to see what this pattern would look like. The thickness of the line is now kind of scaling proportionally with the grid size. Okay, so these are things that we can start to do, create some parameters that we can tweak, and then within that, we have some constraints. Here I have a constraint of a grid and one of two possible patterns for this composition, this image. All right, let's jump back to a less dense version, like the 20 by 20 grid size. And let's talk about code structures. Okay? Now that we've achieved our simple grid framework and we can now throw some randomness in there, we can decide in every cell in the grid, we can draw a different pattern. And of course, you could experiment with this idea, come up with your own pattern. It would create cool results with all kinds of images, not just forward and backward lines, right? You could imagine creating other things using that same concept. We're going to talk a little bit here about code structures. And what I mean by this is we're going to reformat this code here it's going to do the same thing it's doing right now, but it's going to go about it in a slightly different way. It's going to be organized a little bit different way. And this is important because how we organize our code is opens doors in terms of what we can do to take it further. So decisions you make at this stage are going to impact what you're able to do easily with your code down the road. And when we talk about generative systems, processes everything, right? So the ability for you to be able to massage your idea and express certain things is really going to rely a lot on your ability to structure code in a way that lends itself to being expanded and to being expressive. So this is a little bit abstract, but let's give an example. So instead of doing things this way here, we're going to take advantage of the nice flexibility that JavaScript offers us, which is we can represent, we can store functions inside variables very easily in JavaScript. And that opens up like all kinds of interesting structures and patterns we can create within our own code. So instead of doing things this way, we're going to take these two different patterns that we have here, and we're going to create a separate function for each of them. Okay. So to keep things simple, I'm going to call this one pattern1, and I'm going to create another one called pattern2. Okay. I could be a little bit more descriptive here, but I'm leaving this generic because I'm going to ask you in the exercise this week to just experiment with creating your own designs in here, so they won't all necessarily be lines. Okay. So let's take pattern1, which is our backwards diagonal. We're going to put it into its own function here. And notice I'm not even bothering with parameters to the function. This is more about structuring the code, kind of creating different sections for my code and being able to create labels for different sections of the code, right, through the function syntax. So you'll see this is going somewhere. And then over here, we could say, well, now that we've put that into code, into functions, and we're going to just need a single line here, so I'm removing the brackets, we can say here we're going to call pattern1, and here we're going to call pattern2. Okay, so far, not a huge difference. All I did here is I put pattern1 and pattern2 into their own separate functions. Okay? Now, one cool thing we can do with JavaScript is we can assign anything to a variable, including a function. So for example, we could say something like, the selected pattern. We can create this is kind of a pointless example, but let me just kind of get to the point here. We could create a variable here, and then we could say selected pattern equals pattern1, no parentheses, right? We're just going to do the name of it. And then here we could say selected pattern equals pattern2. Okay? And then once we've selected a pattern through our if statement, we could simply call the selected pattern like so, using the function syntax. Okay? So I want to talk about this a little bit because this is important regarding what we're going to do next. So here I'm defining a variable, right? I'm calling it selected pattern, just made that up. And then here I'm going to assign to selected pattern one of these two functions, right? Either pattern1 or pattern2. So these are my functions over here. And then once I've done that, basically selected pattern becomes a synonym, right? It becomes a placeholder that contains one of these two, but I know that it contains a function, which means I can use it as such. I can put the parentheses at the end, and now the code knows, oh, inside selected pattern, there's actually a function. Let's run it. Okay, let's have it do its thing. So we're able to assign functions into variables and then just run the selected function that way. Okay? So that's kind of neat. Now, why this is useful is because we could also take that little step further. So if we can assign functions to variables, you can imagine we could also create an array that contains a number of functions. Okay? For example, I'm going to go back to the top here, and we're going to define an array. Let's call it patterns. Okay? In JavaScript, creating arrays is simple. We just use the square brackets. And then inside patterns, we're going to put, currently we have two possible patterns. We have pattern1 and pattern2. Okay? These are the two functions. This is the name of the two functions that we declared down here. Okay? And now that we've put them into an array like this, doing this little bit here becomes really trivial in JavaScript. If you want to select something at random from an array, you can simply do away with this random number altogether. Okay, so we're going to get rid of this, get rid of that. We could simply say selected pattern equals random. And then we want to get, or not a random number, we want to get a random selection from a list or an array. We can just give the name of the array we want to choose from. Okay, so this is pretty cool. So now we can simply say when it's time to draw a pattern, and see it still works. We're going to say choose a pattern at random from this list here, this array called patterns. Put the result into this temporary variable called selected pattern, and then run that function, because we know that these are all functions. Okay, so we can then use that syntax. So that's pretty neat. The reason this is cool is not only it does kind of simplify our code a little bit, but now it becomes a lot easier to build on this and expand what our little simple generative framework can do. So for example, if we wanted to go beyond 10 print and say, I want to have 3 possible patterns for this, this kind of grid tapestry. I want to have a third pattern here. Let's call it pattern 3. So imaginative, I know. We're going to say this is going to be a half backward diagonal, okay, just to kind of fit with the theme here. We're going to draw our backwards diagonal, but we're going to stop in the middle of a cell. Okay, so we're going to still start from the top left corner, but we're going to stop at grid size divided by 2, which is the center of the cell. Okay, so now we have a third option, which is going to be a half line. And if we want to have it included in the selection, all we have to do now is add it to our list. I'm going to say now the possible patterns are pattern 1, 2, and pattern 3. Okay? We can do this because we've created the structure in the code that allows for this. And now we get this image right out of it. So now we can get 3 different types of drawings in each cell, and then we get this composition, which kind of mixes things up a little bit and creates a little bit more visual interest, from the original 10 print composition. We could add a fourth one, right? This could keep going. We could have some more options here. Let's call this one pattern 4. And the this one, we're going to do the half backward, half forward diagonal. Okay, so half forward diagonal means we're going to start from the bottom left, which is 0 and grid size, but we are going to go to the middle only. So this second part stays the same. This is still the middle. Okay, so let's see what that looks like. So, oh, we don't see it because I didn't add it to my array here. So let's do that as well. Pattern 4. Fantastic. And now I have both full lines and half lines and in both directions. So very neat. So just to drive the point home here, if we did not decide to go with this structure, and again, when you're programming, there's no right or wrong. So there's usually several different ways to achieve the same result, but depending on which path you pick, it's going to be easier or harder to accomplish certain outcomes. And this is one of the things we're going to focus on this series anyway, in this course, in addition to exploring generative ideas, is talking about these types of structures and these structural decisions that are going to have an impact in terms of what you can do. You can't see that decision in the outcome, but it is an impact here in terms of your capabilities. So if we didn't have this array, for instance, we could still do the same, right? We could still do it with the random one method, right, we had before. It would just get a little messier there. We could write this, we can say now we have 4 patterns, so maybe a quarter of the time we're going to do pattern 1. I'm just doing this to illustrate the point here. We could say something like that, right? This could be, pattern 1, pattern 2, pattern 3, and finally, the last case is always going to be pattern 4. Okay? And this is going to work just the same, or it should anyways. Oh, I don't need to run a selected pattern here. Okay, so in this version, let me move that back up so I don't get confused again. So in this version, we achieved the same thing, right? We just took 2 different pathways to get there. Now this one has the benefit that as I was adding patterns to the list, I didn't have to worry about thinking of these values here, right? In this version, I have to think about how do I evenly divide the number 1 into 4 chunks, right? So that I can have these happen. If I decided to, you know what, I don't really want to have pattern 4, I only want to have 3 patterns, right? Now I'd have to worry about, okay, like 1, I have to divide it in 3. So I have to be constantly doing some math in my head and thinking about these implications. Okay? So it's kind of in a way a little bit less flexible. The one benefit this approach has at first glance, though, is that it will allow me to do things like tweak the probability that each pattern will occur. And what I mean by that is that currently, in this version we have over here, where we use the random list selection, each pattern is going to happen the same, equally. Just like when you flip a coin, when you have 2 patterns, this is the equivalent, but it's like throwing a 4-sided dice. Okay, so one of these will come out in the same amount of chance, same amount of probability for each one. With the if statement, we can think about tweaking the probability a little bit. Like, for example, if we made this 0.4, then this one is going to happen less frequently than the other 2. And this is going to change the bias a little bit of this makes pattern 3 becomes a lot more frequent, right? So this changes the overall look and feel of our composition, which is another thing we're going to want to be playing with in generative systems. So this could work, but we could also implement this idea taking the array approach. Okay? So this is the last thing we're going to talk about for this lesson. So this basic way of approaching things here just kind of works, but we're going to try to get a little bit more precise and a little bit more articulate with our code here. So what we want to end up with basically is the ability to say, here's a number of patterns to choose from in each cell of the grid. And I also want to be able to define for each pattern, what's the likeliness that this pattern is going to occur, right? In other words, some patterns might have greater chances than others of occurring, and that's going to allow me to really kind of influence the outcome of the composition while keeping it random. So we're kind of starting to sculpt the randomness a little bit. So let's get rid of this here. Now, again, there's probably lots of other ways we could do this. This is just one way that I thought of for this example. We're going to approach this problem the same way we would approach holding a raffle. Okay, so imagine each of the patterns in our composition are going to be given a number of raffle tickets. Okay, so we might give 10 tickets to pattern 1 and then 1 ticket to all the remaining patterns. And then we're going to put all the tickets together into a big hat, and we're going to pull to decide from the hat what pattern should be in each cell. So logically, the pattern that's going to get the most raffle tickets, so to speak, this is a metaphor, is going to be more likely to get picked. And that's going to make it very easy for us to tweak the relative proportions of each pattern without having to rely on percentages like this, which to me is a little bit unnatural and kind of counterintuitive. So how are we going to program this? Well, we need to add a little bit more information here to our patterns. We need to have, for each pattern, we need to know what the pattern is and what's the probability this pattern is going to occur. In other words, how many raffle tickets we are giving to that pattern. So we're going to transform this array here a little bit, and instead of storing a single variable at each location in the array, we're going to create another smaller array that has 2 elements in it. Okay? So this element is going to contain the function and then the number of raffle tickets we're going to give to that function. So here we're going to say, just for the example, okay, we're going to start with giving 10 tickets to pattern 1, and then we're going to give 1 ticket each to the remaining patterns. Okay? And we end up with this structure with lots of square brackets. Okay, so thankfully the editor here matches our brackets, very useful. So what we have now is patterns is still an array, right? So it's still an array, but each element is a smaller array. So we can have arrays of arrays in JavaScript, no problem. Each element inside is a smaller array that has 2 things in it. At index 0, it has the name of the function, and at index 1, it has the number of raffle tickets. Okay? So let's write a small little algorithm that's going to use that information to select a pattern at random from this list taking into account these weights here. Okay? So first off, we're going to create an empty array. Let's call it the raffle. Okay, picture this is going to be the bag that's going to contain all of the raffle tickets. It's going to start empty. And what we're going to do is we're going to go through this array here. And for each function, we're going to add that function inside the raffle array based on this number over here. So if we have the number 10 here, we're going to add that function to the bag 10 times. And we're going to do the same for all 4 of them. So the first thing we'll do is we're going to go through this array using a for loop. So we'll say for. Now we have 2 choices here how to write this for loop. We're going to use this approach first, and I'll show you the next one afterwards. So we're going to say create a variable called I here, and we're going to count until the end of patterns using patterns.length. So remember, patterns.length is this array over here. It has 4 elements, each of which is a smaller, tinier array. Okay. And then inside of it here, we're going to say pattern, right, is going to be equal to pattern bracket I. And we know that pattern bracket 0 is going to be the function, and then pattern bracket 1, number of tickets or probability. Okay? Remember, they're not really tickets, but this is just the metaphor I have in my head for this algorithm. And hopefully it makes sense to you. So this is one way we can write this for loop. Okay? The other way we can write the same for loop is because we are iterating here over these objects, which are smaller arrays. And we're not interested here in I, in the actual index value of each of these. We could simply define this variable here inside the for loop and kind of do away with this line altogether. So we could simply say for pattern of patterns. So this is the shorthand syntax for iterating over an array of objects, where at each repetition of the loop, pattern is going to represent one successive object in the list. So the first time it runs, it's going to represent this, then it's going to go to that one, and then finally that one. So this is, in this case, I prefer this syntax because we don't need to know the ID or the index of each pattern. We just need to go through all of them. So this works. All right. So what we're going to do here is we're going to say, okay, well, pattern bracket 0 is our function. Pattern bracket 1 is the number of times we want to add that function to the raffle array. So we're going to write a little for loop that's going to count from 0, right, to pattern 1 in increments of 1. Okay. So remember, pattern 1 is our probability or a number of tickets. So the first time this runs is going to be 10. So this is going to repeat 10 times. And each time we're going to say raffle.push. So if we have an array in JavaScript and we want to add something at the end, we can use the push function of the array. We're going to add the function name, right, associated with this pattern, which is pattern bracket 0. So this is going to say, for example, when we get to the first pattern, we're going to say 10, right? 10 is pattern 1, so it's going to repeat 10 times, and each time it's going to add a copy, or whatever you want to think of it, of the pattern 1 function to this array over here. So by the time we're done, right, if we do this for all of them, inside the raffle array, we're going to have 10 function 1s, we're going to have 10 pattern 1s, 1 pattern 2, 1 pattern 3, and 1 pattern 4 to choose from. Okay? And that's going to create a huge bias towards pattern 1. And now we can say let selected pattern equals random raffle. So instead of picking from the patterns array, we're going to choose from the raffles array we just created. And finally, we're going to run the selected pattern to let it do its thing and draw its pattern in the grid cell. Cool. So you can see now we have like a pretty severe bias towards pattern 1 because we set it to 10. Or we could say pattern 1 and 2 are going to have an equal chance, and then we have 1 ticket for pattern 3 and 4. Okay, so now we have once in a while we have some cut up lines, but for the most part it looks a lot like the original 10 print. Or we could get rid of pattern 2 altogether, right? Just put a 0 here without, if we're just experimenting with what our code can do here, maybe we're changing the grid size, or maybe making it smaller and so forth. We're experimenting with sort of the field of possibilities, the field of textures and images our program can generate. We've given ourselves here a series of tools to do that. So again, no right or wrong here, but this is a kind of a nice way to, a nice flexible framework that we can use to kind of add any number of patterns, right? We could make this as complex as we wanted to. This could be, these patterns could include colors, they could include different shapes and so forth. Don't have to be lines, of course. But now we have a little bit of a framework that we can play within to create these random grids with different probabilities and the ability for us to kind of easily take some functions in and out. If we want to take something out, like I said, we could just replace it with zeros, or we could simply take them out of the array altogether. That would work as well. So now we're kind of back to the original design. Or, we could make everything in different proportions and so forth. So we get variations on the theme, all of which are different every time we run the program. And yeah. And finally, another last thing we could add here, because the only way to get a new pattern here is to hit refresh. We could implement key pressed, for instance, or maybe mouse pressed. Let's do mouse pressed. And we could say loop, which is basically going to unpause our program. And then that's going to allow us to click to generate new patterns. Okay. So mouse press is going to unpause, and then in draw, it's going to generate a new pattern here, and then it's going to pause again until we press. Okay. So just kind of a nice little last minute addition, so so we can kind of quickly generate new ideas from our program. Okay, so I'm going to leave it at that for this week's example. What I'm going to ask you to do this week for your creative exercise is using this grid framework as a starting point. Just come up with your own visual interpretation of that grid. In other words, your own pattern designs, your own number of patterns, your own set of probabilities. Maybe you can throw in some color in there. Just try to have fun with it, play with the grid size, and yeah, come up with your own original design using this grid framework. And yeah, have fun, and I'll see you next time.